Here's a fun little game. It's called the sum and product game, and it will help us to solve quadratic equations. Can you think of two numbers that have a sum of 6 and a product of 8? Two numbers that add together to give 6, and when you multiply them, they give 8? Well, it's 4 and 2. Can you think of two numbers that have a sum of 8 and a product of 15? Well, 5 and 3, or 3 and 5. That does the job. What about two numbers that add up to give 5, so their sum is 5 and their product is 6? That one's even easier. 2 and 3. What about two numbers that have a sum of 1 and a product of -6? Trickier, isn't it? Well, -2 and 3. -2 plus 3 is 1. The sum of these two things is 1. And sure enough, you multiply them. Negative and a positive gives a negative. What about this one? You add them together and get -1. You multiply them and give -6. Well, we know that exactly one of them is going to be negative because the answer, when you multiply them, is negative. And it turns out that this is very similar, but 2 and -3. If I start at 2 and go backwards 3, oh, there we are. Then the sum is -1. And we could go on and on and on, right? To find two numbers that have a sum of -5 and a product of 6. And the question is why? Well, one reason is to factorize quadratics so that we can solve quadratic equations that look like this. How? Well, first we will factorize this quadratic expression here, this trinomial, using the sum and product rule. We notice that this, the coefficient of x, needs to be the sum, and this number, the constant term, the number by itself, will be the product. So we are looking for two numbers that add together to give 6, and when you multiply them, you get 8. I think we actually did this one, but let's go through a systematic way. The systematic way is start with just 1, and we're going to write pairs of numbers. 1 times 8 gives 8, so my pair of numbers are +1 and +8. And when I add them together, 1 plus 8 is 9, so the sum is 9. Does this pair of numbers work? Is that the sum that I was looking for? No, I was looking for +6. So let's try another one. What else goes into 8? 2. 2 goes into 8. 2 times 4 gives 8. So I'll write the two numbers that multiply together here, my factors, my pair of factors. And then here is the sum. So just looking at this, +2 plus 4 is 6, +6. Is that the sum that I was looking for? Yes! So these are my wonderful numbers, yay! So those are the numbers that I can use to factorize this. X plus 2, x plus 4 is 0. Do you notice that I like to write, the x in the brackets with a little space there, x in brackets with a little space there, so then I can just fill it in with my pair of numbers, my magical pair of numbers, that add up to give 6, and the product, when you multiply them, is 8. Cool. Now it's factorized. Now we can do the null factor law that we've seen before and solve each of these. Either x plus 2 is 0 or x plus 4 is 0. Beep, beep, beep. And if I solve this one, +2 moves to the other side, becomes -2. This one, +4 moves to the other side, becomes -4. Beep, beep, beep. So either x is -2 or x is -4. We'll try another one. Again, that needs to be the sum, the coefficient of x. I'm looking for two numbers that sum to a +2, and the product is -15. So I would normally start with just +1. Always just start with +1, it's easiest. You can be systematic about this. +1 times something gives me -15. Well, a positive times a negative gives me a negative, and 1 times 15 gives me 15. So my two numbers here are positive 1 and negative 15. I've picked these numbers so that they match the product. I've ignored all the sum, all the other stuff, and I've just focused on picking two numbers that match that product there. Okay, now you ignore everything else, so all this stuff here, just ignore all of that. 1 take 15 is negative 14. Now compare this to the sum that I'm looking for. Is negative 14 the sum that I'm looking for? No. So we'll keep going. Let's try, what else goes into 15? Oh, I know. 2 doesn't go into it. Let's try 3. Do you notice that I'm trying to be systematic here so that I can guarantee that I'll get to the answer? Positive, I'll just try positive 3 for now. A positive times a negative gives a negative. 3 times what will give me 15? 3 times 5. And sure enough, positive 3 times negative 5 does match that product. Now, we'll ignore everything else, ignore all that stuff, all of it. Pretend it doesn't exist. What is the sum of positive 3 take 5? Well, 3 take 5 is negative 2. There you go, write that bit neater. Is that the sum that I was looking for? No, but it was awfully close, wasn't it? What if we try flipping it around? So instead of positive 3 and negative 5, let's try negative 3 and positive 5. We'll check that the product still works. 3 times 5 is 15. Negative times positive is negative. The product still works. Okay, promising. Let's try the sum. Negative 3 plus 5 is positive 2. Yay, that works. That is the one that I was looking for. So now I can write my factorized expression here. X minus 3, x plus 5 equals 0. Because these were my magical two numbers that have a sum of positive 2 and a product of negative 15. And then I can solve it just like I did for the other one. So I'll skim past this a bit. By the null factor law, you know, two things multiplied together, either this is 0 or this is 0. So either x take 3 is 0 or x plus 5 is 0. The solution to this equation here is that x is 3. One way of thinking of it is negative 3 turns into plus 3. 0 plus 3 is 3. And the other one is positive 5 goes to the other side, turns into negative 5. So x is negative 5. So that, my friends, is how you can use that cool little sum and product game to do something, to solve quadratic equations. I will see you guys next time. I hope this has been helpful. Bye, everyone.